Hi, I am Professor D.K. Panda from the Ohio State University. Together with my colleagues Ben, Tu, and Gautam, we are very excited to bring you this tutorial to be presented at the Supercomputing 2026 conference. The tutorial is titled High Performance and Smart Networking Technologies for HPC and AI. As many of you know, we as a community are heading already into exascale. Several exascale systems have been deployed. If you take a look at all these large scale systems, you will see that they're scaling rapidly, both from the traditional HPC workload point of view, as well as from the AI workload point of view. And they're all driven by a combination of multi-core, many-core CPUs, GPUs, high performance and smart interconnects, and also sometimes very AI specific acceleration units. Now, it is not only the traditional clusters are getting larger and larger, you will also see the storage clusters, the data centers, they are also rapidly expanding. And in many organizations, even a combination of these compute, storage, and data centers, you'll be able to see they are working together over local area network and wide area network. So in this context, if you are a network architect or if you are a manager or if you are a researcher, you will have a lot of questions regarding how to build the next generation networks for HPC and AI. You may have questions saying what are the kind of major bottlenecks in modern HPC systems? Why use the high performance networks? What are their architectures? What are the communication stacks look like in the high performance networks? What are the kind of the protocols which brings this network architecture convergence? What are the communication semantics, different features, the management for the high performance networks? How about the architecture and the topology also of these networks? And how to really design software libraries on top of the modern networks and their features to really deliver performance to the top level? And what the kind of the emerging like a smart network interfaces are coming, what are their features, what are their capabilities, and then why do high performance networks deployment are actually being very active these days, especially for AI workloads. And finally, like how can I learn more of these in a hands-on manner? In order to answer all these questions in this tutorial, we'll go very deeply into a combination of these protocols, as you can see on the slide, starting from the traditional Ethernet to InfiniBand native to the RDMA over conversion enhanced Ethernet, the RoCE, and in between all the different protocols and also other networks. In addition to the traditional networks, we'll also focus on smart network interfaces. As you can see, like several vendors are coming up with different network interfaces like the CPU based, there are also FPGA based, and even there are like a very dedicated systems are being designed, like for example Cerebras and all are coming up with totally integrated systems with large scale AI deployment, and they're also developing their appropriate software stacks. Industry is also coming up with very specific network adapters also for running inferences and training. So to put it all together, this tutorial will go into much more detail with all these topics. We'll start with a very high level introduction, talk about like why high performance networking for HPC and AI, bring the concepts behind RDMA, the different kinds of communication model, the semantics, and then we'll try to see how this the two fields, InfiniBand and high-speed Ethernets, are being converged. And we'll also have a set of exercises, hands-on exercises here on a modern GPU cluster. We'll go into a lot of scale-out RDMA networks. In addition to InfiniBand, RoCE, we'll be talking about Omni-Path, Amazon EFA, the Slingshot, etc. And then we'll also talk a lot about the scale-up networks. These are the traditional, the NVLink, AMD Infinity Fabrics, the CXL, and especially the upcoming Ultra-Ethernet, the UA link, and also the the new Ethernet Consortium. We'll also take a look at the overview of the software stacks, especially two of these, like the Open-Fabrics, the older one, and the UCX and the Libfabrics, which are the very latest one. We'll take an example of how to design upper-level software stacks, let's say MTI, while trying to exploit the modern features of the networks. We'll then talk about GPU-aware communication and go into more overview of the emerging smart network interfaces. And towards the end, we'll actually cover some of the high performance network deployments for AI workloads. We'll try to understand the network trends. And finally, we'll try to take a look at some of the sample case studies and performance numbers. We also, while we are exploring or teaching the basic concepts, we'll also have a set of hands-on exercises. And in these hands-on exercises, the attendees will get a very first-hand understanding about the impact of advanced networks on performance. So as you can see in this list, we'll go going over a lot of different aspects of the networks in a much more hands-on manner on a cluster to understand all the kind of the trade-offs a network architect need to understand to design not only the network but also the higher level software stacks. So we have a lot of materials to cover, and I hope to see many of you at the Supercomputing 2026. Please look at the program for all the details of the timings and the rooms. So see you at SC. Thank you.